Ish. Okay, welcome to the evening meeting of the OKCJug Users Group, August 2007. Sponsored by Valtech tonight. I'd like to thank them last minute. Got a door prize, a gift card with a bookmark. It says wisdom. Apparently it makes you wise to use this bookmark. From the book that you buy. I would have brought a real book. But Barnes & Noble shelves didn't have anything worth buying, so go online. That's on tape, and I'm a member. You hear that? This month, Brandon Burk, enterprise architect with Hertz, superhero, leads tall buildings in a single bound, will present on Drools, the JBoss Rules Engine, version 4, I think. And he'll tell you all about that. And without further ado.
Well, you haven't seen the presentation yet.
Or the tall buildings.
Yeah.
Still get a smattering of applause just
because I showed up. It's for the heckling you're going to give me. Okay, so Rules with Drools, business rule development for the rest of us. The goal of this presentation is basically to highlight the capabilities, the strengths, and maybe some of the weaknesses, taking a rule engine approach.
Can you go back to the first slide? What do you mean by for the rest of us? What does that mean?
The reason I named that is typically there's a barrier to entry with rules engines. A, they're very expensive. I was talking with an individual today who has worked with many rule implementations, and he said you can spend up to $50,000 for a license of iLog JRules. One CPU license. So you can't really get a lot of exposure to rule engines unless you roll your own historically, or you have access to some sort of free system. That's why Drools is nice, right? It's open source. We'll talk about that later, but that was that divider. So again, we'll talk about the strengths and weaknesses of taking an approach in a system with a rule engine and demonstrate the actual technical details of Drools. Because of time, it's a pretty broad and deep subject. Technology has got a lot of features, but hopefully you can get a good idea of what's there right now with the 4.0 release, which just got released 3 weeks ago. So the 4.0 is pretty new. I don't have any affiliation with JBoss or now Red Hat. I'm not a committer to the Drools project. Don't plan on it, so I don't have any vested interest in selling Drools or anything like that. So before we look at the technology itself, it's worthwhile to talk about the background of rules engines. It started off really from artificial intelligence. There's a couple of categories of AI that is symbolic. Is one of those categories. An expert system is part of that symbolic AI. Considered applied artificial intelligence, that it's a little bit more realistic in the value it can provide. Not to say that the other areas of AI are not, but people don't as readily implement genetic algorithms and neural networks in their code, right? So an expert system is an area that's had a little bit more traction in the commercial world. A characteristic is that it contains subject-specific knowledge, or you can think domain-specific knowledge, and the analytical skills of a domain expert or subject matter expert. Those analytical skills combined with that knowledge about the domain give it the appearance of being able to reason on a problem, which is kind of interesting. So a process of developing with an expert system is called knowledge engineering. That's what it'll say in the body of knowledge out there about expert systems. I think all of us are kind of knowledge engineers because that's all we work on every day. But a little bit more information. It addressed the expert systems category of development, kind of addresses problems that would normally require a subject matter expert. And what we mean by that is, it doesn't take an expert to go say, write me an application that tracks my inventory through my warehouse. Whereas if you say, write me an application that will diagnose one of 750 skin diseases, it might take a little bit more background, a little bit more expertise in that field, right? So things like medicine, finance, right? Rate this commercial fire policy for these, 7,000 square foot buildings. Well, you're going to go talk to your insurance actuary guy who loves statistics and math and has all of his numbers, and he'll tell you all the details about how to build that application, right? So that's kind of the background of where it's really got a sweet spot. We take the rules of thumb from these experts, put them into this expert system through a couple of methods. Typically the first one is through explicit extraction. Somebody goes and works with them, right? Hands-on, collaborates. Because not everyone thinks in the terms of if-then, right? Not all business experts are Boolean in nature like we are. So there's explicit extraction for developers, and then there's implicit mechanisms that people will say, here's a bunch of test cases, expert evaluate them, and now I'm going to go, thanks for your 3 weeks of work, and I'm going to go write a program to analyze all your test data, your responses to all these things, and derive rules from that. So I haven't personally seen that in practice, but apparently some people have done it. It's another kind of interesting thought that it's generally an expert system is generally used for problems which there's no single correct or exact solution. It can be encoded in a conventional output. So what that kind of means is, you have a lot of inputs and even more rules to look at all those inputs. And when you sit down to say, how am I going to put this into a controller or a coordinator and give me a single response, all of a sudden you start thinking, wow, this is a really big project. I'm going to write if-then-else statements for the next 70 days. Those kind of problems are harder to address in conventional programming versus expert systems. So it's just a little bit of the artificial intelligence beginnings. But doesn't that really sound like a lot of what we do anyways? Yes, but kind of a key differentiator. Traditional problem-solving system, i.e. any Java web app you write, maybe that people put in some information and expect back what to do next. We spend a lot of time as object-oriented developers trying to figure out elegant and efficient and easily maintainable ways to put all of the data about the problem in with all the program logic that controls flow and processing of that data. It's all kind of bundled together, right? We say we have these 6 steps that then, if this happens or this happens, we go to these other 12 steps and we run through that, and then we apply these other 4 conditions, and it's all very, it's all very concise and clear, but at the same time, it's very coupled, right? The difference between a traditional system and an expert system is that an expert system draws a line and it cuts out all of the problem-solving logic in the form of the program and just puts it all in data declarations. Those rules, right? So you express all the things that you think, if this is true, then this should happen. If this is true, then this should happen. You express all that in data declarations, and the program that then manipulates all those really has little to no knowledge about the problem itself. So it's kind of an interesting contrast if you look at something designed in an expert system versus a traditional program. So business rule engines, also sometimes called production rule systems. They're a more confined aspect or confined type of expert system. And the main difference that I've been able to discern between a real expert system and an actual business rules engine is that an expert system usually has a little bit more of an interactive feel to it. And a requirement of an expert system is it has a shell that can interact with that carbon-based process, right? That person sitting there that types in an initial known fact, and the expert system does some things and says, okay, well, what about this and this? And then it kind of guides the person through this shell type arrangement. There's a couple of products out there that fit that specific space in the Java world. Chess, the Java expert system shell. It's not open source. It's not free for commercial use, but it's something that actually is a true Java expert system that can be customized to your needs. A business rule engine has the same core architecture, however, it doesn't always have that shell of interactivity with that human. It can just be called by programmatic processes, right? And it's a little bit more flexible in the terms of being a back end or a decision logic for other systems. So, and it focuses on scalability of lots of rules, whereas an an expert system shell. That's not necessarily the focus. So, some aspects, business rule engine by Drools is Turing complete. So it can pass the Turing test. Focuses on knowledge representation. It's able to express propositional and first order logic in a clear, declarative manner, right? So what that really means is it's able to clearly show you what logic is. If this is true, then I'm going to do this, and you don't have to sift through a bunch of source code to find that out. It's able to scale to a large number of rules, tens, thousands, hundreds of thousands of rules. It takes those rules, it matches them against facts or the known data at the time to try to infer a conclusion, which then ultimately will result in actions, other rules, firing, and in the end, your goal is you have an answer or a suggestion or a direction to your problem.
Are there situations where you can't come to there are no conclusions that can be derived?
So Michael asked, are there situations where you can't come to a conclusion or no answer could be derived? And the answer is absolutely yes. And a lot of that hinges on the quality and the amount of rules you have to match or how confined you expect the data to be inputted into the system is. So how does it work? Two primary architectural components that drive a business rule engine. One is the problem dependent, right? Those domain focused declarations. These are normally called your rule base or your rule set. Some older materials will call them the knowledge base, but I don't really like that because I think of the Microsoft knowledge base and keyword searching. I don't think that's a good term for it. But the secondary primary component of this design is a problem-independent program, right? The inference engine. That is typically what it's called. That's not a Drools terminology or name that apply to it. They have this inference engine, which really doesn't know if you're trying to diagnose a skin disease or if you're trying to rate an insurance policy or whatever. This inference engine is just going to look at the rules and match the facts against what it knows and ultimately produce you an answer. So kind of interesting, this is just a tool like anything else we do in software development, or it's another approach to designing systems. It still runs on people. And I would submit that even more so than a conventional system, you might be rolling everything yourself. It really does rely on you having access to subject matter experts. I mean, that's what really shines, right? So you need access to the people who really know about the domain to help you build that rule base.
So your rule base could be called subject matter base.
Sure, yeah. Yeah, it's a subject matter engine. Business engine, sure. Knowledge engineers, it could be a business analyst, it could be a user, an executive, it could be someone in your company who's an owner of the system. More than likely, from my perception and what I've seen, it's a mix of developers and business analysts. So I saw this from the Drools documentation. I saw it and I thought, hey, I need to draw something like that. Well, why am I going to draw it? They look the same. It's kind of a bird's eye view of the system. In the left, you see the production memory. That's the rule base, or the store, where all your different sets of rules are going to go. The big box in the middle, your inference engine, which has a couple of subcomponents. The pattern matcher and the agenda, which we'll talk about a little bit in a second. And the working memory is where we put what we know at the time. So ultimately, when you start off your question, right, or this is what I know right now, the state of things are, put them in that working memory, and the whole process initiates and kicks off and starts matching rules to see what it can start reasoning on your problem. So a little information about, a little bit more information about the inference engine. You saw that box that said pattern matching and agenda. So facts are inserted into the working memory. It's a kind of a temporary working space. It's not a one-shot deal. The inference engine can update the memory. That basically serves as its brain, its storage, right? It said, oh, based upon what you told me, I just was able to figure out 3 more things, and it'll put those in working memory. And then continue working. So it's able to modify and retract information from working memory. The rules are matched, and the facts are stored. It's able to scale to a large number of rules and facts. And when this happens, if you've got, say, 30 if-thens, right? We'll see in a minute. That's basically what a rule is. You've got 30 if-thens, and you submit 6 initial facts. Well, there could be a chance where 3 of those if-thens are true for 1 fact. So how does the rule engine know which one to execute first? Right? When it's matching, how does it know? This is something where, I made a joke about it earlier, the inference engine becomes Dr. Phil. He resolves conflict for us using this agenda. Right? An agenda manages the execution order of conflicting rules using a conflict resolution strategy. So the inference engine saying, yeah, I hear what you're telling me, and what I'm understanding you saying is this, this, and this, so I hear there's a problem here, so this is what I suggest you do first. Right? So that's what it's going to do when it's running.
Why isn't the agenda part of production memory?
Part of
Production memory?
Of the rule base?
Is the subject matter expert and developers, do they come up with what the agenda is?
Yes. It is actually designated on the rules themselves. But it's not used except by the inference engine.
So this guy doesn't actually learn, right? He's pretty stupid.
Well, the inference engine itself doesn't really learn, but it can in a sense in that when it's able to infer new things, it can put those new things that it figured out into the working memory. And so it can do that, it can cycle that iteratively. We'll see a diagram here in a second of how that process actually works. But as it says, this is true, this is not true, oh, well, that means this is true. It can put that new item that it just deduced or inferred back into working memory. So in that sense, it kind of does learn. But it's all based on that working memory, and it's all based on how you develop your rules.
So does that working memory ever get stored in case your system dies?
It can be persistent.
So it doesn't have to be learned. Can you go back and look at what it learned?
I think you can. I think they built some. That's going to depend on the actual implementation of the technology.
Right.
With Drools, I do think they have you can go through a debugging exercise and actually see what the rule flow was at the time in the engine.
Well, what's in working memory is just Java objects, right? So if you can look in there, you can know what Java objects.
But they do have some debugging information too that will tell you the path that got you to that, as far as the algorithm, what rules executed to produce this state of working memory.
But it sounds like it's also kind of creating new Java objects, right? When it infers something.
Yeah.
Interesting to see that.
Yeah. Like that's a good topic for maybe an advanced group demo.
For what kind of dance?
Advanced group.
So if you have an agenda, that gives you...
I don't have an agenda.
Your agenda is built in.
Oh, okay.
If you have an agenda that says, okay, ignore this conclusion in favor of this conclusion, there's a reason why you still want to draw all the conclusions and not look at the agenda first and go, well, this is a more important conclusion. I'm going to ignore this one if it occurs, so let's not even check that flag.
Yes. There's something. I think I understand what you're saying, and you're exactly right. You can express all those things in an expert system, business rules engine. One of the key characteristics of them, as they're modeling the human brain, really, you can assign confidences to a rule, right? And in Drools, they'll call it the salience. You can set the salience of a rule. But basically, you can set this a relative weight or confidence factor. So, if the only known fact you know at the time, I gave this example earlier today, the fruit is yellow, right? I have 50% confidence that it's a lemon. I have 50% confidence that it's a banana. Now, when another fact comes in and it says the fruit is yellow and round, now I have 95% confidence that it's a lemon. And you can weight your rules accordingly, right? So that one will be prioritized And you can use agendas in a similar manner, and you can short circuit out of things that way as well. And we're going to go through a couple examples.
You wouldn't look first to see if it was round, and then not bother with.
So that's the interesting thing.
It's probably a banana.
Well, my glass is you wouldn't look first to see if the fruit was round and then check to see the color, right? Because that would seem like a shorter path. And that's exactly what we would probably do if we were writing the logic ourselves. If this, then these four things. If this, these four things. But that's the interesting thing, and that's the difference in developing with an expert system, is you have to learn to let go of the control of the order in which things happen. And the algorithm, we'll talk about that just a little bit here in a second, that actually takes your set of rules, your 58 or your 5800 rules, the algorithm figures out generally what it should do first. So
by the time you come to that conflicting strategy or conflicting zone, conflicting conclusions, so you have all the data you needed to make a definite conclusion.
So if all the rules are there.
Right.
On the
The
data
rules are sufficient.
it's always based on how many rules do you have to cover your domain, right? And decision tables can play an important part in that as well, which we'll talk about in a second. So the pattern matching approach is forward chaining. This is another interesting thing to keep in mind just about expert systems and business rules engines. Generally, they'll take either a forward chaining or a backward chaining algorithm. The forward chaining, you can think it's data driven. Right? It's doing this. I just learned something new, so I figured something else out. I'm just rolling along until ultimately I don't have any new data, and this is what I've got to show you that maybe this is the answer. Think of it as reactionary. A backward chaining, which is not currently implemented in the Drools product, the way that I understand it is it starts with the end and works backwards to say, what were the conditions that got me here? This is I hit the goal. And I'm going to work backwards through a completely different approach and say, I'm going to hypothesize what could have happened to get me here. So I don't really know what the value proposition is of looking at a problem that way, but I'm sure there's certain systems that it's beneficial for.
Would it be efficiency?
I don't know. I don't know enough about it.
You draw a conclusion and you try to prove it.
They are saying in the future release of Drools, they say in the future release of Drools they're going to add support for backwards chaining as well.
That's jump conclusions, man. That's different than chaining forward.
You guys are being dumb.
branching it.
That's a word essentially. I didn't say anything about that.
You're talking about Greg's wife? Or no, Bob's wife.
So we talked a little bit about how facts are asserted into the memory, and one or more rules can be concurrently true. They're scheduled for execution by the inference engine using agendas. An initial fact ultimately ends up in a conclusion through multiple cycles of this. Drools is a forward chaining engine. And here's a little diagram showing how a forward chaining algorithm, pattern matching algorithm actually works. This is from the Drools documentation as well. So basically, I need to update this where there's a little user actor right here or something like that. But you're going to initialize some information to the working memory and then kick the process off. And at that point, it's going to go in a cycle and just repeat until one of two things happen. There's no more rules found to execute, or a rule that says, this is it, done, and it exits as well. So the working memory and the rule-based feed, you can look at the decisions, select rule to fire, the conflict resolution strategy on the right, determine possible rules to fire, all of those three items. Put a box around and say, insert my inference engine. This is basically how forward chaining works. Okay, so go ahead.
Why is there a line from the fire rule up to the rule base? Rule base comes in to determine possible rules of fire. Conflict said, conflict.
I don't know. I had a similar question earlier today, and I'm just gonna blame it on the Drools documentation. But when the rule fires off, it's going to update working memory, and at that point,
Some rules
really this line here, I don't think it should be there.
Yeah, that is correct. that's an external file anybody can manipulate to generate or put a new rule into that.
Oh, that's a good point. Yeah. So you have a little human being over here, right? And you can be adding new rules to the system at the same time. It's not just a static. Well, at runtime, you can load dynamic runtime. That's one of the strengths.
There's a businessrulescommunity.org, brcommunity.org, and I got a book from one of those guys called The Business Rule Approach. He got some system where modification of the rule base by the rules themselves is part of the whole thing. I don't know if Drools does it though.
Modification to the rule base,
they
by the rules. Well, I'm sure it's possible. As we'll see in a minute, the rules can just execute standard Java as their action. So I'm sure it's possible to say, hey, these 4 things just occurred, and that means reload the rules and add one. Because it's just Java at that point, right? It would be up to you to do that, which would be an interesting study to see when that would actually be useful. Kind of those self-aware, self-learning systems that take over the world. I don't know. So just a little bit more before we get into some code examples. About the Drools backdrop, a little bit of history. It was started by a guy named Bob McWhirter in 2001. He originally landed on SourceForge.net. It's always been open source. The 1.0 never actually got released. They ran into some problems. One was their lack of an efficient algorithm. They initially took a standard linear approach and realized a linear approach for thousands of rules doesn't scale. So they needed some help. More people joined the team. It moved over to Codehouse. I don't really know why.
Bob started code.
Probably availability of SourceForge because it used to be down all the time. But,
it's because Bob started code.
Oh, really? Okay. I thought Nathan Hill started it. Oh, okay. That is one. So the 2.x versions, 2.0 and up to 2.5. Mark Proctor kind of came on the scene. He kind of became the project lead later towards the end of the 2.0 releases, and he's still a project lead. Now, I guess he's on JBoss payroll. I'm assuming that's the impression I get. He may be just a consultant or something like that. But, he was federated into JBoss in 2005. So they said, hey, we have this, we're buying all these open source projects because we need to make money off open source, and we don't have a rules project that we can use in our app server. So they said, hey, here's a good one. We'll take that. And then, so JBoss kind of helped. And that's really a good thing. They financed. They were able to get a lot more inertia in their project and development. And 3.0 was actually a complete rewrite. So 3.0 was released first quarter of 2006, I think. 4.0 was released 3 weeks ago. So they're maintaining kind of a yearly, I guess, not release cycle. Some of the Apache license, which is good, because that's real friendly to commercial endeavors and things like that. We all love Apache. Based on the read algorithm. So this is the actual algorithm that does the pattern matching. And this is where the scale comes into play. This is why a rules engine, when you need to process 697 rules 1 million times, this is why it can perform better than a traditional approach. The read algorithm is a decision-making algorithm that can scale an order of magnitude faster than the next best algorithm, invented by Dr. Charles Forgy, computer scientist, came from the Texas area, and he's basically been working on this for 30 years, and that's kind of what he specializes in. The read algorithm is pretty much the dominant algorithm in almost all the popular even commercial business rule engines. Things like Blaze Advisor, MyLog.
Where did the read term come from?
Read is Latin for net.
Net?
Yes, for net. Network. And so it's a networking algorithm. It's actually pretty interesting to read about, and surprisingly, there's quite a bit of documentation, some of the clearest documentation I've seen on it in the Drools documentation. So, yeah, if you're interested, like that computer sciencey kind of stuff, go for it.
What's the 74 and 79? Why are there 2 days there?
74 was when he first published some information about this algorithm that he was working on. 79 was his first actual paper on it. In 81, he did a revision of it, this algorithm. I think 79, I think, was maybe his dissertation.
It's the public domain.
Yeah. Yep. It's public domain. And you'll hear, you know, if you dig into rules engine vendors, some will say, yeah, we have REAP 3 or REAP 2. Actually, those are all vendor implementations and modifications to it, and they're not open domain. But like REAP 3 is not actually changed to the REAP algorithm, it's just a vendor's implementation. So the Drools project uses what they'll call REAP 00, so it's just been completely, you know, implemented in Java and specialized for the Drools for the Java platform.
This sounds like something you'd want to run on one of those Drools systems.
It certainly could be. Yeah, you want to dynamically allocate more processing power, more JVM process to it. Yeah. Especially if you were using something like this in a major batch run environment, right, where you're processing literally hundreds of thousands of rules. So, yeah. JSR94 from the Java community process. This was several years ago, but Sun said, hey, we should have a spec on rules engines and a standard way to call them. It doesn't cover everything about how to implement a rules engine, but it covers a certain few tasks, you could say. It does provide an implementation for JSR94 as well. So a Drools rule looks like that. Nice little domain-specific language. And really, this is nice. If you looked at Drools syntax in the 2.x versions, it was really ugly to try to specify your rules unless you just love XML. So it was all done in XML, very verbose. And as you see later, as you'll see what we can do in these rules, imagine trying to express it all in XML. It was pretty ugly. But basically, you have a rule, you give it a name, which is just a descriptive name. You can have these attributes. We talked about confidences a little bit. That would be an attribute called salience. So you can have, there's about, I don't know, 8, 10 attributes, something like that, that are able to give a little bit different behavior to the rule. And things that are looked at by the agendas and pattern matcher.
Are those named attributes, or you just have to know in a specific order to put them in?
I don't believe there's a specific order. I think they're just any order you put them in, I think. I'm not positive.
Their name.
What's that?
So their name.
Yeah. So yeah, you put your attribute and your value of that attribute. So if you had, for instance, no loop as a boolean, no loop true would say, once this rule executes, don't ever execute it again for the lifetime of this session. Right? So it's a little bit of added behavior. You would say salience is 100. I'm 100% positive this is the rule lane to fire, and that's a short circuit. Right? You can fire that rule.
Is it a go-to?
Kind of a go-to, yeah.
Define session. It's session where point run through all rules for a particular data set.
Sort of. I'll show you in a second some demos. But this is what it looks like. You have a left-hand side and a right-hand side. The reason they're called left-hand side, right-hand side, the when this is true, then do this, that, the LHS, RHS notations used heavily in the pattern matching algorithm in REAP. But typically, just in expert systems, they'll call that antecedent to this consequent, right, or the condition and the action. That's all it is. It's just an if. Negative. But you can, but the consequent is just standard Java, so you can do a lot of ugly stuff. And they'll even talk about that out there, you know. Rule development has techniques as well, so don't make ugly rules, you know.
You can,
there's an example.
one guy I was talking to would have rules post events to an event queue and have other rules fire when those events arrive. So you can have them signal each other through the working memory and fire off.
Yeah. It's a framework like anything else, and so you could abuse it all day long, and if it works for you, then great. But traditionally, no, you can't nest rules. So this is a little example, just contrived. See, I've got the name in quotes, qualifies for frequent buyer discount. Kind of an important thing to understand. The condition here in the when clause has C: customer, and then an actual evaluation. So first order logic there. Last month purchase count greater than 5. This is not Java, right? Obviously, we don't have any notation like that in Java syntax-wise. Well, this is part of the DSL, and it's going to look in the working memory for any customer objects, job objects that have been put into working memory, and it'll infer their type based upon the name specified as part of the syntax, and it'll look for a getter setter or a public field of last month purchase count, and automatically extract the data and compare it for you. This C colon is how you assign a variable to this. I don't have to add that, but since I wanted to set something to it, if that was true, I get it as a variable and I say, hey, last month's purchase count was greater than 5, you can send an eligible discount code for this customer. They're frequent, they're VIP, right? That's just a simple example.
What if you have 2 customers?
What's that?
What if you have 2 customers that match your criteria?
Yeah, how do you import packages?
Yes. Yeah, we'll get to that. Having 2 customers, I don't know for sure.
Twice, once for each one. The cars for all.
It would depend on how you put them into working memory, and this is all free form, right? So you could address that in your rule too.
Okay.
But yeah, each rule is going to execute for the one object it's looking at and work the one fact.
One at a time.
Yeah. So basic usage. Oh, yeah. Okay. So we're up to my little basic demonstration here. So a little background about this, right? I just wanted to give something to show in a simple scenario, really, how you could apply rules. I don't have tons of rules or anything like that, but we'll see how to use it. I like old motorcycles, and I find myself having to tinker on 30-year-old British bike carburetors, and I don't know anything about carburetors. I'm not a mechanic, but I'll still like to do it, and you can pretty much get a subject matter expert through Google, right? So you Google British bike carbs and troubleshooting, you can get a million million experts saying, well, check this and this, and if it's these things, then it's this problem, if it's these things, it's this problem. So I tried to embody a little bit of that into a sample program.
Use some Google Scholar.
I have seen Google Scholar, yeah. Okay, so I'm going to fire up Eclipse, which I do have the Drools IDE, the JBoss Rules plugin for Eclipse. This is something that
What version is it?
it's associated with the version of Drools, so it's 4.0.
Oh.
Or are you talking about Eclipse?
The plugin itself.
The plugin itself is 4.0. It's kind of gated with the product.
And it's supported by the Drools.
Yes. Yeah, it's not something like maybe like Maven, where you got people writing Maven, Eclipse plugins, and it's not the same guys writing Maven, and so. But it gives you certain things like you can see immediately. I'm in a Drools perspective. I've got a little Drools workbench. Things like new rule project, new decision table, new domain-specific language. It's the logo is a little head, brain. It's not in the closet. I'm pretty sure.
I see. It's like white-eared and.
So we have this rule view, and you can see I have a list of all my rules there. But I'm going to start off by showing you the Java. So this is pretty simplistic. I've got a simple motorcycle object. This object, just so you can see, there's no behavior. There's no data to look up or anything like that in this class. It's just got some attributes. And it's built around diagnosing a motorcycle carburetor. I could have named it something else probably. I'd actually put a little more thought into it. But it's got things like, what's the exhaust color? What is the sound of the exhaust? What's the setting of the throttle, right? Because it's all basically going to feed into the system to try to tell me what's wrong with my carburation. What is the sound of while it's running? Descriptive words, and then what's the engine temperature? Is the engine hot? Is it cold? What's the stroke? Is it a 4-stroke motorcycle or whatever? So just some attributes about that.
Strokes hurt when you don't know.
Well, we can talk about that later because I know you're a motorcycle guy. But the 4-stroke motorcycle, and you're listening to it and it sounds like it's a 2-stroke or an 8-stroke, then it can be your carburation. So, and then I have a diagnostics class. Diagnostics, very simple. And I thought, well, I might build this out later into some other diagnostics about other things about motorcycles as well. But right now, it's just got an air-fuel mixture attribute, some getters and setters, and then a collection of explanations. Right? So my expert will hopefully fill this with reasons and rationale behind. He'll say, yep, your system's rich or has too much fuel to air mixture or too much air to fuel mixture, and tell me why. Tell me the reason why. So again, no behavior, just kind of poses there. And then my diagnoser. So this is where we actually need the Drools metal. This is where the API comes in. The diagnoser class has a diagnose method and a read rule method. So my diagnose method takes a motorcycle object, creates a diagnostics object, and then this is where we actually work with Drools. So we instantiate a rule base. That rule base is our production memory. We have this helper method called read rule. What that's actually going to go out and do right here. We'll step through this because this is really where the interesting things are.
Is rule base just a single rule?
Rule base. No. Rule base is in the API of rules. You have a rule base which can contain multiple packages of rules, and each one of and you get a session off of the rule base. So you'll see in a minute how that works. But so the rule base, we pointed to a DRL file. That's the actual file that contains our rules.
I was just learning a little bit about the method.
That's true. Yeah, it should say read rule base or create rule base or something like that. Yeah. So we get our DRL file, which I'll show you at the end. We get a package builder. A rule base can contain multiple packages, and packages are compiled serializable bundles of rules. So you add these packages to a rule base, and that's what you work with from then on. So we have a package builder, and then we say, builder, add package from this source of rules. And then you say, oh, okay, the builder did its work, we get our package out of it, and we add the package to the rule base. You can add multiple packages, you can have 5 or 10 or whatever.
The rules are compiled, right? You said it's a complete Turing engine.
It is Turing complete.
Turing complete. So
you could have it
in Java. It's not Java binary. These are other files out there that are specified that compile rules in some other type of.
That's probably going over my head a little bit as far as how it works on covers, but I think it is Java binary. Yeah, it's going through Antler, the parser generator, to actually read that domain-specific language. And it's Antler's going to take that. It's going to generate both. It can generate a parser for the syntax, the vocabulary, and the lexer to make sure that it's grammatically correct. And for Java, I believe that will just put it right into bytecode. You can build your abstract syntax tree. Antler's kind of an interesting technology on its own, but.
So the files themselves, they are class files that can be able to find loader and integrated into these regular resources.
Oh, you're talking about the binary?
The binary
package?
File,
Yeah, you can treat it standalone, and we'll look at that a little bit more later too. Yeah, that's how. This is what you would look at. This would be called an in-process deployment. Right? It's not external to the system. To update our rule base, we have to update our rules and recompile our jar file, our project. Well, you can have recompiled, built packages of rules external to your app, and just have it load in that package, that serializable file. Which is probably what you would do in more cases than not. But I guess maybe not. It just depends on your usage. So ultimately, we end up with a rule base that has a package that's been built from our Drool source file. So once we get that, we get a working memory here by calling this new stateful session method. And that's actually new for Drools 4.0. in prior versions you would say, I think, get working memory or new working memory. They renamed some things in 4.0, and then now you have this concept of you get a stateful session or a stateless session, and as you might think, what's stateful and what's not, but they're better for different purposes depending on what you're using the rules engine for. So I get a stateful session that creates me this working memory, and I insert my objects into the working memory, my motorcycle, and my diagnostics, and I say fire all the rules. So I'm going to run this, and it returns the diagnostics. I don't have a main method. I've got a contrived unit test that's not really testing anything. It's kind of just helping me execute the program. I've got a few helper methods that create motorcycles with various conditions. One that normally runs, one that runs rich, one that runs lean, and for different reasons. You can see that the combination of all those attributes is what an expert would look at to say, yeah, it's running poorly because it's rich, the carburation is rich, and this is the reason versus this is the reason, based upon all these symptoms, right? So I have a few methods to create that, and then these test methods. You can see from a client perspective, right, it's no different than anything else. It doesn't know anything about rules engine. From a client perspective, you just get a diagnoser, pass in your motorcycle and your diagnostics to say, okay, give me my diagnostics back.
You know what the smart code?
Yeah, that's in the rules.
Okay, I
Yeah.
didn't see that.
Yeah. Love it. I love it. I love it. We got an expert in here. Look at the spark plugs. Okay, so I'm going to run this. And let's see. Okay, so all my tests executed. I had a handful. You can see each line prints out the diagnostics. It prints out the air-fuel mixture, is it rich or lean, and then a possible explanation. So I have the first one printed out null, and that was for the normal running. It's fine. There's no problem with it. No explanation. I could have defaulted it to normal or something like that. But the diagnostics for the others, I have three that were lean, considered lean conditions, 2 that were considered rich, too much fuel in the air, and different explanations. Right. This one said bad fuel consumption, maybe due to flooding, caused by impurities in the fuel. This one was where it's misfiring because of some different reasons, right? And in the lean ones, I've got 3 other reasons. It's all the same problem, but different ways to fix it. And this is only something you would get if you went over to the motorcycle shop and said, hey, I need to talk to someone who knows a lot about, vintage British bikes. It's the same type of thing, right? You need a subject matter expert to tell you, well, what's it doing? No, it doesn't sound like this. It sounds like this. Well, check that. That's what you get from an expert system. Now, this example, I do realize you could have encoded in if-then-else statements as well. But if you had something, then you want to scale out to 350 rules, maybe Drools would be a better approach, right? So,
especially if you had some kind of user interface to manage the rules for you.
True. It's almost like you've seen my presentation. You guys got any questions about that before we go on?
Well, if you went to
I know you do.
If you went to vintage Japanese bikes, some of these rules are holding, some of them wouldn't.
That's true.
So Japanese would be in here.
So that would be a characteristic you might put on your domain object and have rules that check that. Is this a Honda or Suzuki versus a Triumph or a BSA, right? Yeah.
But if you coded all these, and then you want to do it for Japanese bikes,
You have an analysis and design session.
Yep.
Programmers.
what's in, what's out, and then you got another new bike comes in. I think
It's hard to get a new vintage bike.
it's a new bike for the application, but it's still a vintage bike.
No, I think not even motorcycles. It will be bicycles department. All the bicycles.
Bicycles have carburetors.
Constantly
It was a moped. Moped. You get pedals and a little engine.
I want my bicycle to ride with me.
Okay, so we'll go on. So that was a basic usage. Showed you how the DRL. Oh, actually, I didn't show you the DRL.
Yeah, there was.
Yeah, it's kind of the most important part.
That's the punchline.
Yeah, I missed the punchline, as usual. There's the DRL.
What's DRL?
I'm guessing.
Rules language.
Yeah, I'm guessing that stands for the Drools rule language.
we done with questions? I haven't.
A couple interesting things to note about the DRL. You do have a logical namespace package construct, just like in Java packages. It's not the same thing, but it gives you the ability to logically group your rules together. And you'll also see where we actually look at those package namespaces later on at management time, these rules. You import, this is just like Java classes, you import the Java classes you're going to use in your rules as the actions or the consequence. And then you can see my actual rules that I have here, very straightforward type stuff. You know, that one. So dark smoke in the exhaust rule, right? So the smart is the exhaust described as black or heavy blue. It's running rich. It doesn't actually have an explanation on that one. Here's another one, a 4-stroke cycle. Sounds like it's 8-stroking stroke cycle versus strokes heard. If that's true, then it's rich and it gives a big explanation of why, right? So, and you can just see, you can run down the list. All these examples, they're pretty straightforward, right? There's your spark plug is sitting, right? It's fouling out spark plug.
That's what you
What's that?
the package based. I have a file at a higher level and one file lower level in the package. Then that's really matters.
Well, were you talking about as far as sub packages?
Yeah.
And as far as like resolution of the same name rule or something like that?
Same rule will be existing in 2 files but in different packages. Under the same
Yes.
package.
I haven't tested that to know what the outcome would be. So if you had a rule with the same name in one namespace and in another namespace, what would happen? I don't know the answer to that, but it would be interesting to test that out and see. I'm sure there's some sort of resolution, right? It's gonna have some sort of order where it forces one first.
That way I can generalize if I go upward the file system and go downward.
Yeah. And actually, the read algorithm, it looks at the left-hand side, right? It looks at the condition. So it may not just be the title of the rule. It may be, does the signature of this rule match what I have also, to see which should execute first, right? Okay, so now we've looked at the actual rules. Oh, another cool thing, you do get syntax highlighting from the Eclipse plugin, and it does validate. If I go set this method, set air fuel mixture, if I make some unknown method, it'll throw a red error, say, hey, you don't have that Java class in your class path. Just have to autocomplete? No. There might be some autocomplete. I haven't fully tested that out. They're enhancing all this stuff at a pretty rapid rate, so between what's GA and maybe what some alpha releases are, I'm not really sure. I didn't run into any autocomplete, but I might have just not known how to do it.
How many rules do you have in here?
Well, an easier way to look at it would be to look at my rule view. There's my rule view.
You just want to see the one people.
Go back to the editor. What was the tab that said the read tree?
Oh, yeah. You're the first person to ask about that. That's actually pretty cool. It's pretty cool if you understand the read algorithm. It gives you a graphical depiction of what this is actually what this actually looks like. Where the colors, there's no legend on here. You got to go to the rules documentation, but it does actually explain what the colors mean. Right-hand side versus left-hand side of the node, how it resolves certain things. I'm not going to try to explain it because I haven't fully understood it, but it is pretty neat, And if you were really going to get into this and you wanted to analyze, right, how your rule engine is going to perform and stuff like that, you would crack out the rules documentation and look at this and understand. It's kind of neat.
What's the agenda?
I don't have any examples of the agenda, but there's lots of examples in the Drools examples.
I thought the agenda was a runtime.
It checks it at runtime, but you can check the agenda. The agenda is checked at runtime, but you specify it on your rules. But there's lots of examples in the Drools bundle that it'll give you, and the fact the next example I'm going to show you came from the Drools examples. So there's some things in there that can show you how the agenda works. Any question back here?
Well, it's a basic question on this screen here. I mean, that can help out with documentation, printing that out and showing flows. I mean, that one looks a little difficult, but
Yeah,
I mean,
it's possible if you got a team of people who understand the read algorithm. Because it doesn't, unfortunately, when I pulled this up and saw it for the first time, I immediately wanted to hover over or double click something and say, well, which node is this, right? Which rule or which condition is this evaluating? And it didn't give me that. So I was like, well, it kind of gives you more of just a spatial view of what the read algorithm, right, the network algorithm, is going to do, all the decision paths that I get identified through your rules. And so from that, actually, there is recommendations and guidelines on trying to tune, how broad versus how deep your algorithms are and stuff like that. But it would be pretty valuable documentation if you could say, render this out and print the rules on each node or something like that. Maybe we should submit that as a feature request to JBoss.
I'll vote for it.
What?
You gotta vote for it.
JBoss uses Jira for their bug tracking, so you can go up there, vote on issues, and submit issues, and check their status.
So the read algorithm when it runs, it's very likely to become a lot of separate threads.
Drools is thread safe, but as far as spawning multiple threads, I don't know. You'd have to look through the code to see if it does that. Somehow I doubt it, because it's a pattern matching one node at a time kind of an algorithm. It does a sweep and then it goes down a certain path. And, I can't pretend to really truly understand the read algorithm from end to end, but I don't get the impression that it's like this big multi-threaded type thing where they have to distribute workload.
Well, not that they have to distribute, but it enables itself to be distributed across multiple processes.
That's quite possible, and they do make the point to say that the whole Drools engine is thread safe, so you can multi-thread access to it.
Have you seen anything in any configuration files that describe the size of the thread pool?
No.
And if it did do something like this, controlling threads, how could it run in JGB container?
Good question. It does. It does run a JCB container.
Maybe you can use series of, yeah, keep the one container